Okay, as the introduction, before we proceed to the detailed mechanical design for the pressure vessel, okay, I explain to you about the introductory on the equipment that involved in the chemical process industry. So later you will know which type of the equipment that we gonna proceed to the detailed mechanical design, or other equipment maybe we can just purchase from the manufacturer or fabricator. Okay, in chemical processes industry, okay, there are two types of the equipment which are non-proprietary and also proprietary. Okay, non-proprietary, that means we have a special customized or one-off item for that particular processes. So that means, example, if our process is to produce ammonia that require a reactor, so based on the particular desired output, so maybe we require ammonia with the certain amount and with the certain quality and the condition. So we design the reactor to ensure that we're gonna obtain that certain yield of the conversion of the product. So basically, non-proprietary is designed to meet the particular process. So as a chemical engineer, we will provide the basic information of this proposed equipment. Okay, for the proprietary equipment, okay, all this equipment is designed and manufactured by the specialist firm. That's mean, example, we have the range on the flow rate, on the type of the example of the pump. So basically, we're gonna pass this information to the manufacturer and to provide us to the correct pump based on the condition provided. So we do not proceed with the detailed mechanical design for this kind of the equipment. Okay, the equipment such as pump, compressor, which is the general equipment used in the chemical process plant. So just proceed with the purchasing and then ask the manufacturer to provide the suitable equipment. Okay, as the introduction, okay, in chemical processes industry, the equipment can be categorized into two, non-proprietary and proprietary equipment. Okay, non-proprietary is a special, and this is the customized item or the customized equipment, which that equipment is a one-off item for particular processes. So example, if we are required to produce 10 metric ton of the ammonia based on the particular process, so we design the example, the ammonia required a reactor to have that 10 metric ton of the production. So we design the reactor, or maybe we require also distillation column based on that desired output. So this is called as the non-proprietary. So we have a customized equipment based on that particular process. Okay, for the proprietary, so all the design and manufacture conduct by the specialist firm. Okay, example, we require a pump to have the 10 metric ton of the ammonia. So we require a pump to transfer the ammonia, or maybe based on the operating condition, based on the conditions such as on the flow rate and the type of the material used. So we provide this kind of information to the manufacturer, and this specialist firm will provide to us the suitable equipment to be proceed with. So basically, we do not design the pump or compressor. So all this ready-made equipment will be obtained from the specialist. So just order from them and ask their advice what kind of this equipment or what kind of the pump suitable for our process. Okay, as a chemical engineer, okay, we do not undertake the detailed design. Usually, all the detailed design will be conducted by mechanical engineer. But as a chemical engineer, we will develop and specify the basic information. So the basic design information. What is the definition of the design? Okay, design is refined and plans by creating specification and estimation. So this is the role as chemical engineer. We create the specification, provide the basic design information, and perform the estimation, especially related to the cost estimation of that proposed equipment. And last, we gonna, as chemical engineer, we involved in checking the feasibility of the proposed design. So we ensure that all the design is correct, and then we can proceed with the fabrication and before we can operate it. Okay, the output from this detailed mechanical design are 2D and 3D model, PNID, cost build up estimate, because we already construct the detailed mechanical design that we have identified the material of construction, the operating and type of the equipment. So basically we can come up with the cost estimation of that particular equipment, and also the engineering documentation such as general assembly of the equipment, then the plan layout, and etc. So in overall, the main purpose to conduct the detailed mechanical design is to ensure that overall design solution satisfied with the objective of the project. So if you remember that from the previous topic, that the engineer is not initiate the process plan. So basically, we produce the process plan design based on the needs of the customer. So who are our customer is either the society, management team. So basically, these are our customers. So we will follow the objective that set for the certain project. Before we proceed to the detailed mechanical design, okay, these are the basic data required to design the pressure vessel. So first we need to identify what is the function of the vessel. Example, we design distillation column or tower. So the function is to separate between them, okay, based on that particular process. So we should know the function of the vessel. And second is the process material and services. So what are the material used on the vessel? And the third is we require the operating and design temperature and pressure. So by identify the design temperature and pressure, basically we can have the maximum allowable stress to proceed with the safety analysis. And then we gonna require a material of construction. So the identification of material of construction, it depends on the product or desired product. So example, for the pharmaceutical product, we require more on the stainless steel material, 316 example. So basically all the material construction is based on the desired product as well. So we should have the information on the vessel dimension and orientation as well, and then type of vessel head to be used, whether hemispherical or etc. And then we should have information on the opening and connection required, the specification of heating and cooling jacket or coil if required, especially related to the reactor, the design the reactor, and then type of agitator if required as well, and specification of internal fitting. So maybe we have the fitting it with the instrumentation or control required in the vessel.